We're going to talk about multiplication, the definition, vocabulary, and representations. First, I want you to consider how you would explain 3 times 8 to a person who had never heard of multiplication. Think about what objects you could use around your house, a picture you might draw. I'll pause for a moment while you do this and suggest hitting pause on the video and come back once you have an idea. Welcome back. Let's look at a third grade workbook page. This is from page 174 of our text, and we're going to be using this as our definition of multiplication. So you can see in the picture here that they have 3 bubbles, each with 8 dots in them. You can think about that as 8 plus 8 plus 8. That's going to be a total of 24 bubbles, so 3 times 8 is 24. Notice that our definition down here is that the first number is going to be the number of groups that we have. That corresponds to the 1, 2, 3 bubbles. The multiplication symbol in the lower grades, it's an X. Later on, we'll use a dot because the X means something different in algebra. And then the second number is going to be the size of the groups. That's the 8 bubbles, the 8 dots in each bubble. And then finally, we'll have a total of 24. Now, you might have come up with an explanation that looked something like this, where you had a total of 8 bubbles, and then you put 3 dots or X's or whatever you did in each one. So if I draw this picture and then we examine it with our definition of multiplication, we can count how many groups we have, a total of 8 groups. The size of each group, which will be 3. So technically, this would be a picture of 8 times 3. Now, in multiplication, we can switch the order. It's called the commutative property of multiplication. And 3 times 8 and 8 times 3 give us the same answer. So we don't have to be concerned about order, but from our teacher perspective, we want to make sure that we're representing the first number is going to be the total number of groups. So if I ask you to draw 3 times 8, I'm looking for a picture with 3 bubbles, 8 dots, or something similar. The second picture you see is a tape diagram. You might have heard it called a bar model or a strip diagram, and this can be efficient when we have large numbers. Here we represent 8 equal rectangles in our strip or in our bar, and then just write the number inside each, and that represents 3 groups, 8 in each group, 3 times 8. Let's go to another representation. For the linear model, let's think about how we could draw 3 times 8 and how we could draw 8 times 3. Again, I'll ask you to pause the video and think about this, or perhaps actually do it, and then come back. Welcome back. Okay, so here we have the first one, 3 groups of 8. The group size is 8, so I will have 8, a second group of 8, and a third group of 8. 8 plus 8 plus 8, repeated addition, 3 sets of 8, 3 groups of 8. Down here, we're going to have 8 groups of 3, a little bit harder to draw. We'll have our group size as 3, and now we're going to have to generate 8 total groups. So we can count. I have 1, 2, 3, 4, 5, 6, 7, 8 groups. 8 groups of 3. Next representation. The area model is when we're tiling a region. It's typically easiest to draw rectangles, so I'm going to draw a 3 by 8 rectangle. There's my side that's 3, and then I'll have 1, 2, 3, 4, 5, 6, 7, 8. This is 3 centimeters by 8 centimeters. This is a very powerful representation because one picture represents 3 times 8 and also represents 8 times 3. If we were to think about this as 3 rows of 8, 3 rows of 8, or we could think about this as 8 columns of 3 squares. 8 columns of 3 squares. So again, this idea that we can have 3 times 8 is the same as 8 times 3, our area model is a great model for that one. The next one is a tree diagram or Cartesian product. Let's represent this one with an easier product. Let's look at 2 times 3 and think about the situation where I'm making sandwiches and I have 2 spreads. I could either have peanut butter or I could have almond butter. And then I have 3 jams. So maybe I have strawberry jam, grape jam, or apricot jam. And I might represent it in a tree format. So I might think about peanut butter or almond butter. And each one has 3 options: strawberry, grape, or apricot. Strawberry, grape, or apricot. And I can see that I have 2 groups of 3 right here. In this case, the 2 times 3 is the number of elements in my Cartesian product. Finally, let's go on to some vocabulary. So I could think about a generic multiplication problem where I have n times a equals p. The numbers I'm multiplying I might call factors, and the total I might call the product. So the product of 2 numbers would be a multiplication situation. N we could call the multiplier, a the multiplicand, and p, our product, is also known as the total. Back to our definition. To summarize, we have n is the number of groups. We have a is the size of group. And then p is going to be the total. That's all for this video. Take care. Bye-bye.